Comparative analysis of electronic consumption at home through a single-score perspective. Joy, Noam, Mohammed, Fish, Crush, and Dongulshi. Sangam University, South Korea. Abstract. Machine learning is a state-of-art sub-project of artificial intelligence that has been involved for finding large-scale intelligent analytics in the distributed computing environment. In this paper, we perform comparative analytics onto dataset collected for the electricity usage of a home based on the K-means clustering algorithm using comparison to a serial score with the home basis on the K-means clustering algorithm using the comparison ratio of A per 1 dataset. The performance evaluation shows that the comparison index is similar in numbers of serial score even if dataset is smaller than before. K-means clustering. K-means algorithm is one of the clustering methods for divided. Divided is giving the data among the many partitions. For example, receive data object N and divided data is input data divided K data, each group consisting of a cluster. Below equation is the K-means algorithm when cluster consists of algorithms using cluster function using serial score. Serial score is the easy way to in data each data cluster in data definition and I each data is a clustered inner data and data's definition PI serial score SI is equal to calculate and SI equal max AI BI minus AI. From this calculate SI is equal to the function minus 1 SI 1. SI is close to 1 is the data I is the correct cluster to each thing. Close to minus 1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library scikit-learn in the household power consumption clustering. Analysis. From K-means algorithms, calculated proper cluster things is very important. From the data estimated serial score, the result is K equals 7, each cluster centroid and data prices. Serial score is 0.799 is optimal score. Even if data set is so small, but the A per 1 data set K equals 7, each cluster centroid and data price is serial score 0.810 is the optimal score. From this K-means algorithm, cluster 7's old score A per 1 data set each group centroid and each centroid distance will be an optimal value. From this result, the data set decreases, but the K-means clustering class vector spaces. Is optimal cluster is same situation with before original dataset. Household power consumption rate via clustering. Conclusion. From this paper, household power consumption via K-means clustering use library which is scikit-learn. Malcolm 3 open source personally can easily follow it, and because using the BSC license to real worlds don't have difficulties to do that. From the result, even if the reduced the dataset A per 1, but the serial score and the old clustering result is the same with before. But the population is increased, it can show the clearer result for the classification and vector spaces. Large data to small data is clear to show to the specific result for the serial score, but opposite side is not clearly allowed. Because 4-dimensional vector data from the experiment reduce the estimated time of received huge dataset from analysis.